All about similarity and scale drawings. By the end of this lesson, you'll be able to use similar figures, which are just two shapes that have equal angle measures and proportional side lengths, to find scale factor, which is the ratio between those two similar figures. So go ahead and get your binder, turn to the math section, and get ready to take some notes. Sounds very confusing, but what this really comes down to is the definitions of similar versus congruent. So this is the symbol for similar, and this is the symbol for congruent. And let's start with congruent first. Congruent, you probably already know, means same shape and same size. It basically means equal in geometry. So these two figures are congruent because they have the same shape and same size, even though this shape and this shape are turned different directions or have different orientations. Same for the basketballs. Same shape, same size. However, similar figures are different sizes, but they're the same shape. And if you notice, if I took the angle measure of all these different angles, the angles would be the same, but the side lengths are different. So there's a big heart and a little heart. Same heart, just different versions of it. So before we get to our notes, let's look at this a little more mathematically and just with a couple pictures just to get your mind right for this. Congruent figures have the same size and same shape. So in geometry, what you'll see is you'll notice that the side lengths have 1 line, 2 line, and 3 line, denoting that there are 3 different side lengths here. On this other triangle, PQR, you can see that they have a corresponding 1 that goes with this 1, 2 goes with this 2, and 3 goes with this 3. So you'll see that word corresponding. That means matching. It's the one that it matches with. The same way that this green angle is equal to this green angle. So when all 3 angles are the same and all 3 sides are the same, the shapes are congruent. So you see this as a proof here. Triangle ABC is congruent to triangle RQP. That's because angle A is congruent to angle R, and so on. But this is where we get into similar figures, which is what we're talking about today. Similar figures have the same shape but not the same size. So these are 2 triangles, but you can see that this triangle is smaller than this triangle. So the corresponding angles, if you notice, are equal. This green Y angle matches with this green Y angle. They're the same. Just the same way that this X matches with this X and this Z is with this Z. It doesn't matter that it's turned a different way. It's telling you that they are similar because they have the same size angles. However, their side lengths will be different. The catch is with this is that the side lengths will always be proportional in similar figures. And if they're not proportional, the figures aren't similar. Let's pretend like this triangle on the left has side lengths of 4, 8, and 12. For these to be proportional, they'll have to be following the same ratio. For example, if this triangle is half the size of this triangle, every side length that goes with the other side length or corresponds with the other side length, like this one between angles Y and Z, side P corresponds with side A, it's half the size of 4. Same here, between Y and X, 4 is half of 8. So that matches, and that works. It's the same proportional ratio. And then the same thing happens between Z and X. 12 becomes 6. So this triangle is half the size of this one, which means they are similar figures. The angles are all the same. However, the side lengths are different size. So let's get some definitions for this. Figures are similar if they have the same shape but not the same size. The corresponding angle measures have to be equal or congruent, and the corresponding side lengths are not equal, but they are proportional. Let's apply that information to number 1 here. It says pentagon, which is a 5-sided figure, EFGHI, that's the one here on the left, is similar to pentagon RSTUV. Label each of the corresponding angles. I'm going to use colors to show this, and then I'm also going to write these statements below it. So you should do the same if you have colors, and if not, you can just write the statements below. So first of all, when I look at these shapes, I notice that there's a pointy part of it, of this one. I know there's a pointy part of this one. So E and R go together. And I can tell just that by looking at it. But you'll also notice that E and R are the first letters listed. It goes in order. So if it's telling you EFGHI is similar to RSTUV, those are going to be proportional in the same order that they're written. You'll see what I mean here in a second. But go ahead and underneath it here write angle E and angle R. The next angles that are listed are F and S. You can also tell that this figure has been rotated on its side. If it hadn't been, S would match with the F. It's going in order. Okay? So underneath of it, you can write angle S and angle F. You can probably figure this goes on. G and T, those are corresponding angles. U and H are corresponding angles. and V and I are corresponding angles. So corresponding means they match with the other one, and corresponding angles are congruent. Remember, for a figure to be similar, they have to have corresponding angle measures that are equal. So all these angle measurements are equal, even though the side lengths are different. Let's look at number two. Parallelogram JKLM is similar to parallelogram WXYZ. Determine which line segments correspond to one another. So obviously, these line segments are not going to be congruent. So even though they're corresponding line segments, that doesn't mean that they're congruent line segments. They will be similar. So we look here at these shapes. I can see that they're kind of facing the same way. They look the same. And if you also look at the way that they're listed, JK is listed first, and so is WX. So JK is here, and WX is here. That means that they're proportional, and it means that they are corresponding. These are the matching side lengths, even though they're two different shapes. So the same way that they match, K and L is going to match, and so is X and Y. If they are corresponding and they're matching, so are these in green, and so are these in yellow. Now let's get into this more math side of things. Let's talk about scale factor. Scale factor is the ratio of corresponding sides in a figure. And you can write that ratio as new over original. That sounds kind of confusing, so I'm going to show this as a picture. Here's an example of two similar figures. You have this smaller triangle and this bigger triangle. If you look at each of these corresponding sides in purple, 5 to 10 got doubled. 3 to 6 in green got doubled, and 6 to 12 got doubled, just like in the picture I showed you earlier. So when you look at this figure to this figure, it's times 2. Or you can think of it as being multiplied by 2 over 1. Remember, every whole number has an invisible 1 underneath of it as the denominator. So that's the ratio that I was talking about it getting multiplied by. Each side length gets multiplied by a ratio. Sometimes the ratio is a whole number like this. It's bigger. And that's what makes an enlargement. However, sometimes when we look at it the other way, we can think about it like we start with this figure. If we look at starting with this figure and we went to this one, it's getting smaller. That's called a reduction. And if we multiplied it by a half, then it would be getting smaller. This is another ratio. So that's what I mean when I say that a scale factor is the ratio of corresponding sides in a figure. If it doubled in size, the scale factor would be 2. If it got half the size, the scale factor would be 1 over 2. So a scale factor greater than 1 indicates an enlargement. That means if a figure is twice the size, 3 times the size, 4.5 times the size, then it would be getting bigger. That's an enlargement. However, the opposite is also true. A scale factor less than 1 indicates a reduction. If you've ever seen Honey, I Shrunk the Kids, those kind of movies where people are getting really, really small or they're shrinking, like Alice in Wonderland drinking her little small potion, that's a reduction. But whenever she does the drink me and gets really, really big, that's an enlargement. So less than 1, a half, a third, whatever, that's a smaller. And then a scale factor greater than 1 means it's getting bigger. And then for figures to be similar, they have to have the same ratio or scale factor for every side length. So we see enlargements all the time in real life with photos. This photo is being enlarged to form a 16 by 20. What's the scale factor being used? To get that 4 to a 16 and that 5 to a 20. So obviously it's getting bigger, so it's an enlargement. And it tells you that in the problem. But also, you can probably tell that 4 times 4 is 16 and 5 times 4 is 20. But if you don't know that, you could always divide. The new divided by the original, like the ratio. So if you take 16 divided by 4, or 16 over 4, written like this, you get out a 4. So 4 is the scale factor. It has to be true for both of them, but you already know 20 divided by 5 is 4. So the scale factor is 4. You can also write that as a percent. So remember, we are at percent by moving the decimal over 2 times. The decimal in 4 is here at the end, and you just move it over 1, 2 to make a percent, since percent means out of 100. So it's a scale factor of 400%, but for our purposes, you can just write 4. So number 4 is a little bit different. This is a reduction. A map is being reduced to form a pocket-sized version. What's the scale factor being used to reduce the map? So the only reason this is a little bit different is because it's going from big to small. However, the process is still the same. You take the new image and take the side length divided by the side length of its corresponding side. So 6 over 24 would be what we can find our scale factor with. 6 over 24 is 1/4. It's supposed to be a fraction that's less than 1, because it's getting smaller. We're starting with this one and we're reducing or getting a reduction. That means that we have to get a number less than 1. That's what this means here. Less than 1 means there's a reduction. So it should be a fraction. Don't be scared if you get a fraction as your answer. And you'll get the same thing if you do 3.5 divided by 14. You'll get 1/4 or 1 over 4. So your scale factor for these two images is 1/4 or 25%. We see scale drawings around us all the time in real life. A lot of the times I see them on like social media, on photo editing apps. You can use scale factor to either enlarge or reduce your picture so it can fit certain widths and lengths. Two-dimensional and three-dimensional objects can be represented with a scale drawing or scale model. These are just different ways you can put scale drawing. You can say scale model. And again, you see those with maps, photographs, and blueprints all the time. So here's some practice below here with a table in this shape. Go ahead and take a second, pause the video, and try this by yourself, just filling out this table, and then press play whenever you're ready to check. Keeping in mind that SF means scale factor. So I'll go through the first one for you. Let's look at it this way. The scale factor is 3. So every side length here needs to be multiplied by 3. So side AB is 5. So 5 times 3 is 15. And then make sure you write your units centimeters. The next side length is BC. 13 gets multiplied by 3, give you 39 centimeters. The next side length is CA. That's 12. And that is multiplied by 3 to give you 36 centimeters. Let's look at the next one. You're not given the scale factor, so you're going to need to find it. So you find that by finding AB. I see that it is 5, and it has gotten smaller. It's gotten to 3.75. Remember, the ratio we're going to use is new over original. So just like we found those other side lengths before, we're going to take this new divided by the original. That's what a ratio is. It means division. So 3.75 divided by 5. That's going to give us a scale factor of 0.75, 3/4, or 75%. So we'll do that for the other value here. We need to find the new length of BC after a reduction of 3/4 or 75%. So go ahead and multiply 13 centimeters by 3/4 and then put your answer here. Should be 9.75. And then let's move on to this last column. If you haven't done so already, go ahead and do all this now because I'm going to just put the answers in when you press play. All right, so it got multiplied by a scale factor of 1.5. So that's an enlargement since it's bigger than 1. So all these side lengths, as you notice, are getting bigger. So here are a couple of practice problems for you to try. I want to specifically look at 6 and 9 because these are the kind of questions I see all the time. So I want to go over these, then we'll be done. So let's look at number 6 first. It says triangle PQR, that's this triangle, is shown below. Its original lengths are multiplied by 2.5. When you have an original triangle like this, that's called the pre-image. This new side length, P prime, Q prime, and R prime, that's the image. That's what it's going to become. And you'll notice that it has these little symbols. Looks like apostrophes. I would say prime in math. So I say P prime, Q prime, R prime. Now, I wanted to show you this problem for that reason, but also because even though I know that this triangle is the smaller triangle and it's going to have an enlargement, it's going to be getting bigger since it's multiplied by a scale factor of 2.5. What I want to suggest that you do is whenever you're given a triangle like this and it tells you to find a new one, go ahead and draw one just like this. Go ahead and draw as close as you can to a triangle. It doesn't have to be perfect, just a quick sketch, and just label it just like the last one. So P, because I'm going to put a little prime here. That's P prime, just like you have a P here. Q is going to go down here in the corner, and I'm going to put a little Q prime. So even though it looks like it's corresponding or congruent, side lengths are the same, it's not congruent. I'm going to multiply it by 2.5, but it just helps to have a picture here. That way I can do this really quickly and easily. So when you do that, you can see that this 8 gets multiplied by 2.5, and you're going to go ahead and fill it in on the new triangle. So you know that PQ is what equals 20 centimeters. You don't get confused because sometimes you get confused on, well, maybe I think I just found PR or the new PR, and you didn't. You found P prime and Q prime. So go ahead and make sure that you do that, making a new picture, even if it's not exactly right. Make sure it's close to what this other triangle looks like so you can show your work a little bit easier for yourself. It's kind of messy, so I'll just go and read it to you. 37.5 centimeters, 42.5 centimeters. All right, let's look at number 9, because this is a great question about proportion. So it's a good review of what we learned earlier in the year. says Susie walks 1.5 miles to school, or 1.5 miles to school. When she looks at the map, it shows that the scale factor is 1 centimeter on the map is actually zero point 0.5 or half a mile in real life. And it's asking for the distance between Susie's house and her school on the map. So I want to point out that when it says what 1 centimeter equals on the map, that's your scale factor. That is your scale factor. So you could write that two different ways. You could write it as 1 centimeter over zero point 0.5 miles, or you could flip it and write it the other way. Just like that. As long as you have zero point 0.5 miles together over that 1 centimeter, it's almost like this is the new unit rate. So this is going back to what we learned about proportions earlier on in the year. Since I know that she walks 1.5 miles to school, I need to make a new fraction and write the miles on top so it matches with the other fraction. So 1.5 miles goes on the top of my new fraction over some amount. That's what the question's asking. The distance between Susie's house and school on the map. So since I'm looking for this in centimeters, I need to find a missing value between two fractions like this. That's whenever you cross multiply. So you multiply what you have across, and then you divide by what's left. When you do that, you'll see that you get 3 centimeters on the map. Alright guys, that's it. If you made it to the end of this video, please put in the comments your least favorite chore. I love taking out the trash, but I hate putting the trash bag back in the can. Just can't stand it. Today we learned about similarity in scale drawings. Now you should be able to use similar figures, which now you know are two shapes that have equal angle measures and proportional side lengths, to find that missing scale factor. So go ahead and go to your calendar, click any other assignment you have left for the day. Let me know if you have any questions. Bye!